Hello students, today in this lecture we will discuss about what is chip thickness ratio and what is the relation of chip thickness ratio with the shear angle and rake angle of the single point cutting tool. So to understand that, first let us understand what is the meaning of chip thickness ratio. And to understand this, let us draw again the simple basic elements of the machining that are required. So for that, let us draw the figure. If we draw a workpiece from which material is removed, you can see over here the main tool moves towards the workpiece and it starts removing material from that workpiece. So over here, as the chip is moving from this particular direction, here the chip cracking starts. So this particular angle at this point with the horizontal, the shearing takes place, and that's why the angle made over here, this angle is indicated as the phi, and this angle phi is called as the shear angle. Similarly, if we again mention main important terms, this is the workpiece, this is chip, and this is the tool. Now over here again, if we draw over here a particular line, in the case of single point cutting tool, we have seen that if the cutting tool is like that, then angle made with this horizontal, this angle is called as the back rake angle or the rake angle. Similarly, as tool is inclined at certain angle over here, so this angle will give us nothing but the alpha, that is the rake angle. So these are the two angle, rake angle and the shear angle. Now what is the chip thickness ratio and what is the equation for that? So to understand that, let us see, if we are removing this much of material from the workpiece, that means if we are planning to remove the material of thickness T1, and after removal we know that always due to certain forces plastic deformation takes place, and due to plastic deformation the material removal gets elongated, and that's why there is a certain enlargement in its thickness. That means this is the chip which is removed, and this is nothing but the thickness 2. So these T1 and T2 are the two important parameters to understand the chip thickness ratio. So I hope now you have got the clarity what is shear angle, what is back rake angle, and what is the thickness T1 and the T2. Now let us discuss the main important point. So you can see figure over here. In this again, let us summarize. This T1 is called as the uncut chip thickness. Similarly, you can see over here, this is T2 which is obtained, that is in the form of the chip after removal of the material, that is it called as the cut chip thickness. So this T2 indicates cut chip thickness. So now what is the chip thickness ratio? So chip thickness ratio, which is indicated as the R, it is nothing but the ratio of uncut chip thickness to the cut chip thickness. So this is the basic equation for chip thickness ratio, and as we always know, this T2 is obtained after elongation, that means this T2 is always greater than T1. So from this ratio, T2 is at the denominator side, that's why we can say that chip thickness ratio R is always less than 1. So this is the basic fundamental knowledge required to derive the relation between chip thickness ratio, shear angle and the back rake angle. So again, simply just say this phi over here indicates the shear angle, this alpha indicates the rake angle, and the L1 and L2 that are nothing but the length of metal to be cut and length of the chip respectively. So you can see over here now from this simple figure, look at these two different parameters. First triangle, that is OMP, and the second triangle, that is ONP. And in these two triangles certain angles are indicated, and how that angles are obtained, that now we will see. So here we will enlarge that particular portion. So that part is nothing but the tool. So let us write the important angles available. So first one is, we know that shearing takes place in this particular direction, and that's why the angle made over here, it is called as the shear angle. So this will give us shear angle phi. Let us just name it O M P. Similarly O N and P, and this is the tool. Now as this is the right angle triangle, this angle P obtained is nothing but the 90 minus phi. Now again let's see over here, if we draw a perpendicular at the point O, then we say that this angle which is made with the tool, this angle is called as the alpha. And as we know here, this is the right angle triangle, and that's why the remaining angle, that is nothing but the 90 minus phi. So if we see triangle NOP, similar as shown over here, just we are writing the angle at other parts. So this angle O which is indicated over here, this angle O, that is nothing but the summation of these two angles, and that is 90 minus phi plus alpha. So again we can write it as 90 minus phi minus alpha. And as this angle N, this is the right angle triangle, so this is the 90 degree. So this angle P will give us phi minus alpha. So over here this angle can be indicated as phi minus alpha, which are shown over here. So this is how different angle indication is obtained in this particular figure. So I hope this understanding is very much important, that how these angles are obtained in this particular figure. Other than this, just mathematical steps needs to be followed to derive the final relation between this chip thickness ratio, shear angle and the back rake angle. And to derive this equation, there are certain assumptions are taken, and that assumptions are, the first one, that is the in orthogonal cutting, chip width is same as of the width of the cut. That means chip width before cutting and after cutting remains constant. And similarly, the another parameter that needs to be understood, that is volume of the material before removal and volume of material after removal of the chip remains similar. That means if we write in the mathematical form, we can write as volume of material to be removed that is equal to volume of material removed. So now if we write the volume of material to be removed, that is thickness T1 into B and length L1. Similarly, if we write for the removed material, then it is thickness T2 into width into length of that chip removed, because we have written b common for both the side because this is the first assumption. So we can write over here T1 divided by T2, that is equal to L2 divided by L1. And as we know, T1 divided by T2, that is nothing but the chip thickness ratio, which is equal to R. So this chip thickness ratio can be also explained in the form of the length, and equation for that is given over here. So these are the important parameters that you can obtain from this figure very easily. And now I hope you have the clarity that how these triangles and the derivation between this triangle is obtained. So now we will further discuss to derive the final equation by using these main important triangles. So now, considering this triangle OMP and the another triangle, that is ONP, which we have discussed. So we will draw the figure for both the cases. First one, so this is triangle OMP and the another triangle. Listen over here very carefully. This N is the right angle triangle. So N needs to be indicated over here, and the other parts, that is O and P. So from this figure, how to draw these two figures, this is also important. Now just write the angles available in it. This angle O, this is the 5, this is 90 minus 5. Similarly over here, this angle O is nothing but 90 minus 5 minus alpha, which we have obtained, and this angle P is 5 minus alpha. So now let us see what is this MP. What is the value of MP? So we can see over here, this is nothing but the uncut chip thickness. So it is indicated as T1. Similarly, what is T2? Then this T2 is nothing but the value of NP, which is cut chip thickness. So over here, this is the T2. So now let us use the equation to consider T1 and OP. Similarly, over here consider the equation which consists of T2 and this particular value of OP, because we want to now similarize these two triangles. First one is the OMP and the second one is ONP. So now write the equation for the case of triangle OMP. We can write sine phi. So as this is the angle sine phi will give us MP divided by OP. So the value of MP, that is T1 divided by the OP. So if we write in the form of OP, we can write it as T1 divided by the sine phi. Similarly, if we write for the case of triangle ONP, then we can write as this is the angle which we need to consider. So we can write as cos phi minus alpha equal to Pn divided by OP. And this Pn is nothing but the value T2 divided by the OP. So in the form of OP, we can write it as T2 divided by cos phi minus alpha. So this is the equation number 1 and this is the equation number 2. Now we can compare both these equations very easily. So the next compared equation can be written as OP equal to T1 divided by sine phi equal to T2 divided by cos phi minus alpha. So again we can write this equation as T1 divided by T2, that is equal to sin phi divided by cos phi minus alpha. Just simply using mathematical rule, we have switched these values T1 divided by T2, and that's why sin phi written over here. So now this T1 by T2 is nothing but the chip thickness ratio that we have studied. So we can write it as R, that is equal to sin phi divided by cos phi minus alpha. So this is the first basic equation which gives the relation between chip thickness ratio, shear angle and the back rack angle, and let us name it as equation number 3. So now we have obtained the simple relation between all these three values. Now again we can modify this equation by simply using the basic mathematical step which we will discuss now. So just keep this equation in mind, and now we will modify this equation further for the calculation point of view. So now let us write R, that is equal to sin phi divided by cos phi minus alpha. So we can write it as again R cos angle phi minus alpha, that is equal to sin phi. So now if we modify this equation cos phi minus alpha, it can be written as R cos phi into cos alpha plus this sign changes, that means we can write it as plus sin phi into sin alpha, that is equal to sin phi. So now to obtain again final consideration, divide both sides by cos phi. So dividing both sides by cos phi, we will obtain the equation as, here you can see that this cos phi can be cancelled out. Similarly at this bottom side, if we write cos phi, then sin phi divided by cos phi result into tan phi. So modifying that equation, we can write as R cos alpha plus tan phi into sin alpha, that is equal to sin phi divided by cos phi, which is nothing but the tan phi. So writing the values tan phi on one side, we can write as R cos alpha, that is equal to tan phi minus tan phi, which we have written over this side tan phi into sin alpha into R. So now taking common value tan phi, it will become 1 minus R sin alpha. So in the form of tan phi, we can write this equation as R cos alpha divided by 1 minus R sin alpha. So this is the again another modification of the final equation. So this equation again gives the relation between chip thickness ratio, shear angle and the rack angle. So there are two different variations available. Based on the given values, you can consider any of the two equations for the examination or calculation point of view. So I hope you have got the knowledge that how to derive this particular equation from simple mathematical steps and by considering two important triangles, and how to write the angles available in it. So modifying or rewriting that two equations again, the first equation, that is R equal to sin phi divided by cos phi minus alpha, and the second equation, that is tan phi, that is equal to r cos alpha divided by 1 minus r sin alpha. So these are the two major important equations required to obtain the relation between the chip thickness ratio, shear angle and the back rack angle. So for easiness or for to repeat entire topic again and again, you can watch this video to understand the relation between these different angles and how to obtain different angles in that particular true triangle to consider final formula to obtain or to derive this overall equation. So looking forward to see you all in our next lecture. Up to then, thank you.